All right, well, welcome to the next edition. And I think Irene, I asked you if we could do this, and then Tali, I brought you in because one thing that I notice is that people in the facade industry are a little bit tribal in terms of their specific geography or region, and they like to push what is relevant to the project typology that they see with the performance criteria. But especially here in North America, we have such a vast spectrum of climate zones and inherent relevant performance criteria or code requirements subject to either that climate zone or the specific requirements there. And something, Irene, that we spoke about is the how the weathering patterns are progressing and evolving, and that may shift that criteria. But you have these different themes around bird-friendly glazing in New York, aggressive energy codes in heating-dominated climates, but it's so specific to those regions, where it's enforced by code, or it just has something to do with the local practices. So to end that rant, thank you both for coming on, but I thought this would be really interesting just because, you guys worked together in a global sort of engineering facade consulting practice, but operated in very different regions. So I think it'll be really interesting to hear, how that meshes and some of the conflict that you've seen in your experience together. So I guess to start, do you think, are there certain like practices that you would say are practice throughout the different offices and regions, and you try to stick to like a standard method of practice, or is there very clear acknowledgement that like every project is going to have a specific requirement depending on the region or zone or the client's requirements?
I would say that, a lot of it is very project specific. I like to start with climate and site building typology and client requirements. But as a regional sort of facade practice, we have pretty consistent best standard practices, but just which aspects kind of take precedent do depend a lot on the specific project. Like, for example, in California, we focus a lot more on solar performance and controlling the solar heat gains, whereas in New York and the East Coast more generally, and I will let Tali weigh in, but it is a much more heating dominated climate.
So I think both Irene and I have worked all around the world, actually. So it's not just East and West Coast and Northeast and Southwest climate. So I think that's pretty useful. So it's not just North America, to answer your question. And I'd say you have some allowance depending on where you are about what you can do and where, and that also counts for this country too, right? So I was just looking at an email that came through about using a laminated podium glass wall for a very tall span, which I already know based on where they said in the article, it's got a super low wind load and isn't really a thermally, a place with thermal concern, right? So, there's certain things can be done in certain places because of that, right? And then there's what Irene is referring to, which is just best practice, right? So if we're going to do an opaque wall almost everywhere, we're going to try and do the right thing for the wall, no matter where it is, sort of independent of its location. And that may end up being the same type of wall buildup, right? So yeah, it just varies.
And funny enough, you guys are this is just how my brain works, going in 17 different directions, because as you were just speaking now, I thought of a really interesting topic that I think is relevant today, in that we just had a pretty horrendous storm, Tali, here in New York. And so, working with a lot of clients all over the country, a lot of times they'll say, well, does my Florida client need anything right now? Or, do I need to make a visit down south? And I actually looked at the weather in Nashville this week, and it's going to fall below 12 degrees Fahrenheit.
Yeah.
And here's a market where does I think Tennessee have some type of code in terms of fenestration U factor requirements? Sure. But are they enforced is number one question. Number two question, are they relevant to the climate today? So a huge challenge with a governing board like NFRC, especially that was once driven specifically for the residential market and is, migrating more and more so to the commercial market, is you try to create this framework that can apply to all. And this idea that we have specific climate zones, and then you're going to have different U factor targets specific to that. Do you think that framework is relevant today? I mean, just thinking about how thermal performance is not discussed in Nashville, yet how much heat loss are you going to get right now in a 12-degree Fahrenheit day when you're trying to maintain the heat in your interior space? So do you think climates are changing and weather is changing, and that's the underlying issue?
The codes and the U factors that go into the codes themselves are, there's a lot of rigorous calculations that go into that to justify those numbers. For certain states and certain jurisdictions, they don't require the latest codes. So they will be referencing previous code cycles, which does put new build buildings at a higher risk of not being designed optimally for the latest weather patterns and heating and cooling requirements. And I don't want to jump to politics this early in the conversation, but I mean, a lot of that is driven by politics and what the appetite is for addressing climate change if people believe in climate change. And I'll just leave it at that.
Yeah, but if you have a client who is interested in acknowledging it, then there are some tools out there that are sort of, I guess, loosely bundled under the overarching umbrella of resilience, right? And you can apply more recent weather data to extrapolate further out, the changes in wind and heat and cold and water, and design your building accordingly to be able to address what we think is coming, right? So, exacerbated weather conditions all around the country.
And that's kind of part of where our role comes in as facade consultants, is to bring best practice to our client to say, there's the code, like bare minimum, what you need. My professor referred to it as, the bare minimum to keep you out of jail. But, obviously we want to do better than that and give the client a building that is resilient, that doesn't take on these risks that we are seeing in the weather patterns.
Yeah. And I'd say, even though it's not codified, people, are not blind, whether they're political or not. Like, they see, after Hurricane Sandy, people know if you're by the water in New York that you've got to address flooding. Anyone who's worked in the Southeast, like by Louisiana, they know that they've got to deal with wind and water issues, and Texas. And, it's clear whether it's codified or not. So it depends on your client, really.
On that note, if you had to put a number to it, and obviously it's going to be, a plus or minus whatever, but how many of your projects, if you look at 10 projects you're working on today, how many do you think are, for the most part, taking the prescriptive path versus a performance path? In that, are you following, we have to hit a certain window to wall ratio per the prescriptive path, or U factor per prescriptive, or are you doing an energy model? And then, on wind, are you doing an ASCE 7, or do you have a project-specific wind tunnel study? Just, I guess, on the project typology you guys work on, do you think that has to do with level of sophistication of client or budget?
Absolutely. I would say about 90% go performance-based on the energy side. On the wind side, I think maybe, Tali, you probably,
I'd say,
with your structural background, my background is
depends on
more
the project.
mechanical.
Yeah. I mean, if we have a sophisticated client, they'll go for a wind tunnel test. It depends on the project. If you have a sort of a more bog standard type of building, or like lots of existing building renovations, they're not doing wind tunnel tests. It's all code based.
If you had anything to say on it in terms of outcome of the building as it relates, because forget about building to code legally so you avoid going to jail. I don't want to set that as the benchmark to how we should be building, but like in terms of client satisfaction, mitigating remediation work down the line, occupant satisfaction, like how would you rate the effectiveness of spending that up front versus the end, as compared to the end outcome?
I'm going to put aside occupant comfort for a second and just talk about optimization and economics. There's a lot of savings to be had by designing for like say a wind tunnel test, right? Designing for where you actually are and taking advantage of the shielding of the local microclimate effects. If you're in a city and you know that this plot adjacent to you is going to be demolished for whatever reason in the next 2 years, right? So you take that into account and you design for appropriate wind pressure. And then you can be a little bit more intelligent about what, how much aluminum you're throwing at your design, and how many stiffeners you need. And we were also concerned about embodied carbon and not using too much material where you don't need it, right? So you can design smarter if you have more correct data, right? If you can do that in the first instance, then the occupant comfort will fall out, right? Because then you'll have fewer issues due to noise, due to wind, or chimney effects and oil canning and listening to that sound, in your space. In my previous building, we used to stand and watch a corner office literally sway under the wind load. I mean, it was ridiculous, right? So if you can design that out, then there's savings to be had and people will be more comfortable.
Yes, absolutely. But in terms of the envelope and mechanical integration, I think that's everybody will acknowledge that's important in terms of being able to downsize your mechanical loads with an envelope first approach. But what do you see the interaction or collaboration look like between envelope and structural engineer of record and being able to minimize or optimize your structure rather, depending on wind loads and cladding attachments? Are you typically brought on early enough where you're involved in that discussion when they are designing the structure based on cladding pressures?
Yeah. Usually there's a basis of design report where you're stating to the structural engineer what you think their assumptions are for stiffness for the edge beams. If there's any sort of exterior sun shading happening, then there's another interaction where those things are picking up so-called environmental loads, wind, ice, snow, particularly for horizontal sunshades. So they need to take that into account. And there's an extra step, which may or may not come out in a wind tunnel test, where that's included. And then they know how to reduce like tributary area reductions for the structure. So yeah, there's an iterative cycle where you're making an assumption, you're stating it to them, they come back to you and say what they can do. And then they too can then go around the building, design for peak points, right? Save a little bit of tonnage, and actually design the building for what it's going to see rather than just using a worst case assumption and rolling it out across the whole building and pouring a lot of money, extra money into the structural cost.
I think that's what hopefully you communicate well to clients, and whether you're the end user or the general contractor or owner, and having the adequate or appropriate envelope consultant on board. It's almost like selling somebody on those upfront costs for them to then, like you said, optimize the structure, be able to save on how much insulation they're using, and optimize all these design decisions allows them to save money in the end. And you'd think it's such a small, soft cost in the grand scheme of things versus relative to the hard construction costs of things, that it would be like a no-brainer. But the role of an envelope consultant, would you say it's more driven by the market or the project type? Meaning, if you're working on an institutional project or an airport or a hospital, it's like, of course we need an envelope specialist. Or is it like, oh, envelope specialist in Boston or Seattle or New York is like the cool thing or the normal thing to do, so of course we're going to get one? Where, in terms of like national coverage, do you see it have more of an impact? Is it the project type or more geographically driven?
I think it can be either or both. I don't think I've really
Have you
thought of
seen a
it from
difference, I guess, is a better way of asking, if you're working on a project in San Francisco versus Austin or Louisiana? Do they have a different taste or appetite for listening to your recommendations?
I would say we typically get told like, oh, it's typical in Florida that you just use single laminated glazing, and then we would try to push for a higher performing envelope that can help achieve energy savings and like acoustic and thermal comfort that comes along with insulated glazing units. So we've had those types of conversations. Thankfully, the owner and the client were receptive to those recommendations. So it's more anecdotal in the sense of like what's typically done in a certain location versus receiving actual pushback from our clients.
Do you often think about, and Tali, it's good to use the example of where you used to work and you would be able to measure, see this direct impact, because I think selling people on mitigating solar heat gain or incorporating sunshades or whatever, it's a much easier sell if either you're occupying the workspace that has that so you can point to it, or you correlate it to how you'd want to live at your home. Do you often use those analogies or comparisons when trying to sell a client on making certain decisions or having them operate in a certain framework, in terms of thinking about, there's always been this like battle of the wall and the window to wall ratio, but then you have somebody think about being in their apartment in a high-rise building, and well, do you want to compromise that floor to ceiling glass or their views? So there's always that balance in terms of what's the healthy building decision versus, what type of space does somebody actually want to occupy?
Yeah, I think that's kind of encroaching on the architect's design intent. So usually leave it to them to do the selling, and from our side, we let the numbers do the talking, like let the energy model and the cost savings that comes out of it be more convincing. And I guess I was just on the last question, I was thinking while Irene was speaking, I've been on projects in various locations around the country where it's like an opinion from a doctor, right? You say what you think is best practice, and then they can choose to ignore you and get a second opinion. So I've had that happen too. Or you get booted off the job if they think that what you're saying is just, not going to happen or not cost effective. That's happened as well. Yeah, so I've seen it all, and I think it's sort of independent of location. But there is, I'd say, back to the location question, probably in certain areas there's just a general price point which is a bit lower. That I'd say the coasts might be a bit more expensive, right? Dollars per square foot for an envelope versus maybe the middle of the country, what they're used to. So, people have like a sense of what they're expecting to pay. And if you start encroaching upon something that's a bit perceived as higher quality because it's going to cost more, then people start pushing back.
I'll ask you to sort of I know you're both engineers, but try to put the architect hat on for a second. And, what, I guess I'll ask each of you individually, what's something you feel some type of personal tie to, or you wish like you're like, you want to like squeeze them and like, how do you not understand this? In terms of what you wish you saw more of across the board, as some people want to see lower U values or energy operational carbon savings from that standpoint. Some people really care about noise mitigation. So, Tali, you appreciate that we have OER requirements as it relates to acoustic, but you go somewhere else and they're like, I don't understand, why am I going to pay for a thicker light or laminated glass to mitigate noise? Until you're in that Boston hotel and you can't sleep at night and you're like, now I get it. So what's one thing that like for years has stuck with you that you feel like you're trying to sell to them and it's just not resonating? I'm putting you both on the spot here, but there's got to be some recurring theme over the years of something that means a lot to you that you feel like you constantly have to resell this notion or this idea.
I think something that I've had a couple of conversations around, which is kind of going back to the question of code. It's something that's not codified, but is a safety issue, is glass containment. And a lot of times with safety glazing, clients choose to go with fully tempered glazing because it's cheaper than laminating, but then it doesn't provide that containment. So that's a conversation that we have to do glass risk assessments on our projects, especially if it is full height glazing where you don't have a pony wall, for example.
Taking notes on this, keep going.
Yeah, I was going to say the same thing.
Oh, nice.
Yeah, no, because I have a problem more generally with the notion of tempered glass being a safety glass in the code, full stop. And then what happens when it's double glazed, and then what happens when it's triple glazed, and that sort of addresses your containment sort of question. I think that there might just be, holes in the code, and that it helps to be coming from a global practice where you can kind of compare and despair between the different around the world, how people approach things, right? So like certain codes in Australia, for example, address glass fins, and the US, ASTM 1300 doesn't at all. And then you've got people who are like going out on their own and trying to, define how we should be approaching the design of certain elements because they're not covered in the code. So like more like holes in codes. But I'd say, yeah, I agree with Irene. I was going to say safety too. And then that then leads to, build-ups, makeups, which then leads to thermal and cost.
I'm smiling because you have 3 topics now that I really want to go into. So you just started something, Irene. But on that note, I don't want to sound like a provocateur, but I think like the biggest changes happen, after crisis, whether it's like, for structural engineers with fire escapes, there's a requirement every 5 years you have to have a design professional sign off on the welded connections or bolted connections from a life safety standpoint. Why? Because a Drexel student fell off a fire escape, and now there's some code that's very heavily enforced, at least in this area. Same thing you could say around bird-friendly glazing. You reach this tipping point. So you always, Hurricane Sandy, like you said, you reach this tipping point, all of a sudden now things change. And that glass retention thing, I think, is super relevant and important. One thing that's really interesting in Europe is that the toggle systems are required, especially in SSG applications, just to have an additional means of glass retention, which is incredible that's dictated by code or enforced by code. All the IG fabricators have now retooled to be able to do that. And fine, this is normal practice. Not to say it's more or less expensive, it's just the norm there. Toggle could be one solution, but also, what about more captured systems? I mean, does that resolve that problem instead of SSG?
I think we were talking just about monolithic, fully tempered, whether it's SSG or not. I mean, if it's fully captured on four sides, it's maybe a little bit better, especially if you run a wet bead around it, but that only gets you so far.
And the idea of tempering versus laminated, it's that actually came up when we spoke, Irene, that you
I
push
think that
for
was
more
an example that I
laminated.
raised. Yes.
I was recently in a glass fabricator's facility last week, and they had a heat soaking oven, and they're like, yeah, of course we do it. It's just kind of, and we recommend it. I don't think enough I want to say instances, but I don't think it's vocalized enough. The concern over spontaneous glass breakage, especially even like we're talking about facades, not interior glass, but like showers, how relevant something, the shower doors, how relevant something like that is. And, in the few New York City projects I've been exposed to with nickel sulfide inclusion, you look up on the elevation, you could see it, the crack propagation, and you try to use binoculars, try to identify others. And at that point, what do? Do you tape it off? A lot of times they might put up like a wood board, or at least deglaze or cut out the exterior light and put up plywood or something until you get do your full investigation and find out what's going on. On that note, is there a push to temper less when not required? So only in safety glazing applications, whether it's a balcony or within 18 inches of the finished floor. Do you think there's this notion of just temper it all because, that's the easy button?
I think I would only limit it to locations that require safety glazing that don't require containment, because otherwise, I mean, I don't know why you would want to heat treat to a fully tempered state if you don't need it. But
Yeah.
Tali, maybe you have.
No, I was going to say
other
first
thoughts on it.
choice is not to fully temper monolithic at all. First choice is get away with heat strengthened. If it needs to be safety glazing, then it's laminated. And then if it needs to be fully tempered for whatever reason, then you put it somewhere where it can be protected and contained so that it won't, if it does break, then it won't fall out in somebody's head, rain outside, or, say it's the middle light of a triple glazing, for example, then it's contained on both sides. But you can adjust, your glass load share to avoid that. You don't really need it. And then if we're talking about something that's like patched or point supported, I don't know, that's like a little bit out of fashion maybe these days. The fashion changes over the years, so maybe it's not such a question. But if it has to be fully tempered, then you have to reassess, what's happened. This is back to what Irene was talking about with a risk analysis, a risk assessment, and seeing what happens if it breaks. Maybe you add a netting, maybe you just make it laminated, which is all my first choice all the time. All the time. Yeah, there was somebody, actually a senior person in our team, who actually was in a hotel room recently, and the shower exploded and completely cut up his foot.
Oh.
So this issue is near and dear to my heart about spontaneous breakage. Yeah, and unfortunately, people don't really. I mean, it happens. For many, many years in this country, people said it doesn't happen. So I guess it's good now that they realize that it does happen. That's good. But often there's not so much a study on the back end of isolating the butterfly and bringing it to a lab and looking for the inclusion and figuring out who made the float and trying to find out if there's going to be a problem with other pieces of glass from that same campaign, and trying to get ahead of the next breakage. So I feel like it's on like a break by break basis, and there's not a lot of research and forensic that goes into it afterwards. People just kind of accept the break and replace it and don't really think about it until it happens again and again and again.
Might not be the platform for this question, but I've been trying to think about and ask, like, how far you can take a laminated monolithic piece of glass, even if you were to add 2 coatings on it, basically not create an insulated unit, and how much performance you can get out of that. So you hit all of a sudden, you might hit the acoustic criteria, you'll hit the safety criteria, maybe you could hit the solar criteria. And the question is, can you hit the appropriate U factor depending on how much glazing there is just with the monolithic assembly? Do you think that could be a path?
That makes me think of vacuum insulated glazing. If you want the kind of low embodied carbon, thin, filled up vacuum insulated glazing is going to get you a much better U factor, even compared to, standard IGUs.
I'd say without VIG, for most of the country, probably no.
I'd love to see more of it. I mean, I think there's,
Yeah,
we could have a separate
right.
discussion, and there is more stuff to come on that. I'll say that. Yeah, I mean, this push of like accepting an IGU for what it is, and ultimately everybody's like, oh, what warranty are you going to get? Some offer 20 years, some offer 10 years, but it's not to say like after 20 years, the IGU is just going to fall out of the building. Ultimately, with that hermetic seal around the perimeter, there is going to be some moisture ingress, and that's why you have desiccant to dry out the airspace, but at some point you run out of desiccant. So accepting like whether that's 25 years or 35 years, I don't know, but your structure should last 100 years plus. I think everybody would probably agree on it. So you're going to end up replacing components, and hopefully you've built in a form of a retrofit strategy with your facade. But if it's a well thermally broken frame, the frame should last, and ideally you're just replacing IGUs as needed. But maybe could be one day a push to get away from the concept of an IGU, and like you just said, with the concept of a VIG unit. But also, there are a lot of existing buildings out there, especially in New York and others, especially in California, with monolithic glazing that might be able to last for a really long time. And alternate retrofit strategies, I think, need to be talked about more in terms of maybe not films, but storm units or storm windows. I think for the appropriate application can be very important, so long as it's an operable unit and you have access to clean the glass. There's not too much heat buildup within that cavity. But in terms of like low-hanging fruit with upgrading existing buildings, do you think that's a viable solution?
I think it depends on the type of building. I haven't seen that for commercial or institutional type projects, really. For one project we did years ago with more of a historic component, there was a push to keep the aesthetics of the original window, upgrade it, and then add an interior sash. But then it was treated more like a rain screen, which was kind of interesting. That was the first time I've done that. But yeah, in terms of not replacing the existing and adding interior only, I've seen that more on residential only.
Yeah, I haven't seen that on any commercial projects. But I do like the idea of integrating operable units, especially in milder climates. Like even in Los Angeles, there are so many days where the outdoor temperature is very comfortable, and it's, if you open the windows to let the solar heat gain just kind of be able to escape, then you end up saving a lot of energy. You let people kind of connect to the outdoors, but it's very specific to each project. Obviously in an area where you have air pollution, you probably need to think carefully about what the quality of air that you're letting in. Obviously, there's a lot of acoustic concerns if you're in the middle of downtown, but conceptually, it's a great idea.
One thing that can be challenging and limiting, I don't know if you would say the role you play or want to play as an envelope specialist is, I would think, hearing the client's wants, needs, setting the benchmarks or criteria in terms of balancing that with the design intent. But we were talking about precast earlier and some of the challenges associated with designing a precast building. And what I found is you see a lot of architectural precast in some cities. Maybe it's contractor and supplier availability, or maybe it's the architects have an appetite or a knowledge or know-how to design a building around it. In terms of the system selection, material selection, detailing, do you play a large role in that in terms of aiding the architects?
Yes, if we get on board early enough, we do a lot of studies just looking at material options. Sometimes it's driven by carbon, embodied carbon. Sometimes it's driven by cost. Sometimes it's driven by performance or aesthetics, or a combination of all of that.
Yeah, and then there's the whole giving a structure to what it wants to be based on how the building is put together. Does it have terraces? Does it have setbacks? Is it one smooth plane? Like, does it lend itself to a window wall or a curtain wall? What's the maximum span for a precast element? Will you have a problem later with creating continuity of the AVB around the brackets? Like, is it the right solution for that climate? So it's all of the criteria that Irene just mentioned, plus sort of how the building is massed and what does it lend itself towards? Which is
Do you
the
see an
fun
appetite?
part.
And I'm kind of, this will be somewhat interesting because I think you're going to have vastly different experiences here. Irene, I'd imagine you see a lot of prefabricated systems in California and on the West Coast. A lot of times you see these large format mega panels, and it's not a matter of are we going to do that or not? It's this is what we're doing and what contractor are we selecting? They did a case study. It was a Heinz's project in California. It was a large format GFRC mega panel system, and like we would never see something like this in New York. And a lot of it's just maybe contractor availability. But one thing we see a ton of in New York is hand laid brick on mid to high rise construction. And Tali, maybe you could help me out here because I don't understand it at all. In terms of from a schedule standpoint, forget quality. I think with enough monitoring, you can make the quality work. But from a price and scheduling standpoint, how they can make that work and how they don't look towards either precast or prefabricated systems, even like a mega panel system with thin brick on a track or something, how that is not the more advantageous approach. In terms of hand laid brick, in especially new construction, do you think that's very market driven, supplier or contractor availability driven?
So two things. I've seen a mega panel project in New York that
Of course
islanded.
we have them. Of course yes, we
And
have
I feel like a
unitized
lot of
everything here.
contractors are kind of jumping on the mega panel bandwagon, following in Island's footsteps. So, and sometimes that's a great solution globally. We've seen it overseas too, like in Asia. And then in New York with the brickwork, well, let me just address thin bricks and what our UK colleagues call brick slips. Those have a really nasty durability problem where they pop off over time. So from our experience, we probably would never recommend them. Which then, if you have a brick aesthetic, then leads you back towards doing a proper brick wall where you've got two whites and you have a chance of, taking advantage of the cavity and insulating it properly and waterproofing it properly and building it correctly. And then I think it's just based on local labor experience and quality and having the people who are going to be at the coalface and installing it, knowing what they're doing. And then that just comes from what I've seen just down to, the GCs and the subcontractors' experience of working together and knowing that they're going to get a quality project. So yeah, kind of like, you go through, we just talked it through, right? That you go through a panelized approach, which is everyone's first suggestion, and then go to a smaller panelized approach, and then go to a stick-built approach, which is the last choice, usually just based on economics, but sometimes governs based on experience and labor and cost.
Is that kind of abstract to you, Irene, to see how much? I mean, we have a deep pool of masons here and craftsmen, not to say it's great quality. If you see some beautiful Cook Fox work, I'll give them a shout out. And in Chelsea, beautiful designs. Do you not see a lot of that out there?
Yeah, we don't see a lot of brick in California. I don't know how much of that is driven by the seismic, design requirements. We are working on a building in Fort Worth right now that will have brick, so that's pretty exciting for us to be working with a kind of new cladding material, new to us, kind of. Yeah, definitely don't see that much in California, and I think it is primarily driven by the seismic concerns.
Is there any reason you didn't recommend or suggest like a brick inlay and precast, or at least it's adhered in a concrete, so you're not on a track, or you're not using some light adhesive? At that point, does weight become a concern relative to a traditional hand laid brick job?
So my problem with precast is I know there's clean ways you can span joints these days. It used to be a jointing issue, but if you can sort of hide your joints behind handset zipper pieces, let's call them, that's not so bad. But for me, it's always been about it depends where we are in the world, right? But if you have a concern about continuity of your AVB and your precast brackets are penetrating through to sit on your edge of slab or onto your edge beam in some way, right? Then the only real way to get continuity, how do you do it, right? What do you do to get continuity around it? Do you rely on tape? Do you rely on spray foam? Do things crack up when buildings move? Do you off gas? And I don't want to say injure, but not improve the quality for your occupants in terms of health and their lungs. So it's not fantastic. There's really not a great solution. Our favorite precast, I'd say, is a sandwich panel where you push that whole problem outboard of the inner withe, and then that becomes a cost and weight issue. And if you're going to be doing that, maybe there's a cheaper, better way to build up a backup wall.
Do you just mean whether you're going to apply spray foam or mineral wool to the back of a precast panel? Essentially, you're getting interruptions at your slab connections. That's what you're getting at. And
plus the popping off that we talked about before. So, we concerned about making sure that there's a test regime that demonstrates the thing is going to last and be durable for its design life and beyond.
So surprisingly, one topic we really haven't addressed here is fire safety and mitigation of smoke spread. That is an evolving code and evolving requirement. Not to say it's just as much of a life safety issue as glass retention and anything else we discussed. It's interesting. I remember in my inspection days having to monitor unitized panels going up and the interruption of your smoke seal at your P-clip anchors and not understanding that you have, a direct channel for smoke to spread right through there. And that was, I don't want to say like an accepted standard practice, but it's one area that was always overlooked because when you have your EJ, you're just looking at your typical section cut right through the center of the slab, not at your anchor locations. Do you see a lot of scrutiny, attention to details when it comes to just fire safety, smoke prevention in terms of spread from floor to floor?
Totally. On the interior and on the exterior, I think every time there's a fire on a building anywhere around the world, people's hairs on the back of their necks raise, and everybody, certainly amongst the Arab community, starts talking to each other about what happened and why, and what do we need to pay more attention to in the future, right? So specifically talking about the last fire in Hong Kong that happened with all of this HDPE netting that went up in flames on the exterior, thinking about how fires start inside spaces and then when there's a breakage through the window, when and how that happens, and then vertical fire separation, which is what you're speaking about at the edge of slab conditions, how the detailing is sorted, where the plane of the wall is off the edge of slab. Sometimes if you've got a structure with an exterior column and you've got an edge of slab going around that, then you create a chimney, right? Modular detailing, how that comes together so that you have continuity, both vertical and horizontal fire separation. The containment and what do you call those? The barrier, sorry, I've got the wrong term, but it's the new thing in the New York City law now about having compartmentalization to reduce,
avoid the chimney effect.
If you're having a rain screen, to reduce that whole chimney across your whole wall. So yeah, everybody worries, and a lot of people were pulled into everything post Grenfell, which was 2011, I guess, or 14, I can't remember the date. But people were pulled into the assessment of what happened there as well. So yeah, factors into everything. Worried about use of FRP in certain systems, right? How much plastic is too much plastic?
I mean, there's still, I think, a lot of unknowns around what does it mean to have a 45, 60, 90, 2-hour rated system, and when is it or is it not appropriate, whether you're talking about a lot line condition or whatever it might be. And if there's one question where I think like you could ask 10 people across the country, there's a lot of hands that would go up and say, I don't know what to do here. I don't know what I'm talking about in this specific area.
So I feel like I've been reading the code a lot, chapter 7 for a few projects, and bothering some code consultants and then bothering some ICC people who wrote the code. And you're right, I think there's a lot of non-consensus, but somebody wrote that chapter and you can get to that person and you can request a meeting with them and try to delve into it. Sometimes the letter of the code is a bit confusing, but the intent of the code usually is clear. So if you can understand what they're trying to get at, and then apply it to your particular situation, then usually you find a way what you should be doing. But yeah, it's super important. I feel like that's something I've been doing more and more the last few years. I'm not sure why. Turned into a fire engineer.
Of course, but I think I don't know why it doesn't sit well with me, but there's not a you or there's not an Irene on every project, and I think there's that's what
there's authority having jurisdiction. Somebody has to sign off on this project, and it's their responsibility to make sure that it starts with egress, right? That's the only way these projects get permitted, right? So it starts with fire and egress, and it ends with fire and egress, right?
Yeah, of
So
course, but don't you
that
think we have there's a resource constraint in terms of Department of Buildings or just code officials or people that can genuinely take the time to enforce all these regulations and codes on every single one of these projects?
I mean, legally it's supposed to happen, right?
Yeah, I mean, I think it's a professional responsibility that
Yeah.
Yeah.
It's the back to
they
get
can't
out of
just
jail,
let
right, Irene?
exactly. Yeah. Yeah. Yeah, and
I
when you
mean, there,
layer all of these performance requirements and, project criteria, safety has to be at the top always.
someone's stamping and signing all of these projects, whether they're big or small, whether they're in the most landlocked state or the most high profile project, right?
Hmm.
Well,
And
there's
that, yeah.
you guys will both appreciate this being engineers. There's only two soft classes, non-technical classes they make you take as an engineer. One communications class. I went through mechanical background, so I think well, the civils had to take communications. I don't know if we actually technically had to, so that's why many engineers can't communicate. But I
I
think
didn't have that class. I'm a bit older than you, but yeah, we'll talk about schooling later.
okay, and the other one is I think there's at least we had a project on it on ethics. They teach about business ethics, but engineering ethics is like I don't know how
Yeah.
that's not at the forefront of every semester,
Yeah.
especially if you
And
go
I
into
mean,
practice.
internally at Arup, I don't know if other engineering companies have the same, but we have to take ethics training every few years. The training expires. I mean, it's not just related to things like it's business ethics, but yeah, we do have to go through that training and just ensure that we are kept up to date with our ethics training.
Yeah, and
Yeah.
even independent of which firm people work for, even if they're a sole practitioner, in order to keep your professional engineering license up to date, you've got to do that for your continuing professional development. Ethics is part of it. Yeah, needs to be there.
I enjoyed this conversation with both of you. You both came with insights and dressed appropriately and feeling healthy and not sick, and everybody put on a pretty good face.
Tali, are you sick? I'm recovering too. I think, yeah.
Yeah.
Trying to get over the holiday sniffles.
Yeah. Well, I think we'll see both of you in future shows and maybe workshops, and definitely see clips of you on the internet pretty soon.
Okay, we're
Thanks for having us on.
Thank you so much, Adrian.
Thank you, guys.